subscribe to this channel. Do not forget, subscribe. At this junction, we'll be looking at drawing the Lorentz structure of the following compound. In drawing the Lorentz structure, there are some rules that we need to follow. First, determine the valence electron of the various atoms in those compounds. We are looking at the Lorentz structure of water molecule, ammonia, and methane, which is a natural gas. Let's first start with the water molecule. To first, we need to look at the number of valence electrons present in the water. In the water molecule, we realize that there are 2 atoms of hydrogen and 1 atom of oxygen. What is the valence electron of hydrogen and what is the valence electron of oxygen? Let's look at hydrogen. Hydrogen has a valence electron of 1. So we get 2 electrons here. So which means here we have 1 times 2. So in oxygen we have 1 oxygen here, which means we'll be having 1 times oxygen. The valence electron of oxygen is 6. So we are saying 1 times 6. So when you do the math, 1 times 2 is 2 valence electron. 1 times 6 is 6 valence electron. How many valence electrons are present in this particular molecule of water? We have 8 electrons. So those 8 electrons, we are using them to draw the valence electron of water molecule. We say the valence electron of the Lorentz structure of water molecule will be, we realize that hydrogen cannot be the central electron, but the central atom here is oxygen. We put oxygen at the top. Since there are 8 valence electrons, we are about to arrange them. Since there is a lone pair, we are not going to draw this particular compound straight. Hydrogen come on the other side, and the arrow come on the other side. So you put hydrogen and hydrogen, and you realize that each of those bonds represent 2 electrons. So we are saying 2 times 2. There are 4 electrons that have been removed from the 8 electrons. How many electrons remain? 4. So those 4 we're going to distribute there, even that oxygen will be certified in this particular compound. We realize that on the side we put 2. Each of those represent electrons. 2. So in doing this, they give us the Lorentz structure of water. Then we move to ammonia. In ammonia compound, we realize that there are 1 atom of nitrogen and 3 atoms of hydrogen. What is the valence electron of nitrogen? We realize that there are 1 nitrogen here. So we are saying 1 times 5. 1 times 5 is equal to 5. So there are 5 valence electrons of nitrogen in this particular compound. So there are 3 hydrogen atoms in this particular compound. So and the valence electron of hydrogen is 1. We are saying 1 times 3, which give all the number of 3 electrons. So altogether the valence electron formed in ammonia is about 8 electrons. So we are going to use the 8 electrons to draw the Lorentz structure of ammonia. So now we realize that hydrogen cannot go as the central atom. So we are using nitrogen as the central atom. So now hydrogen is the central atom. So we distribute the various electrons in the compound. So we realize that nitrogen has the power to bond with 3 main compounds. So here we put hydrogen here. We put hydrogen here. We put hydrogen here. So since there are 3 hydrogen, we have 1, 2, 3. And each of those lines represents 2 electrons. So since that 8 electrons here and we have 2 bonds here. So each of those bonds represent 2. So we have 2, 4, 6. There are 6 valence electrons in this particular compound. How many remain? 2. To be able to satisfy the nitrogen, we divide the valence electron to the place that don't have electron. So we bring it up here because here is where the lone pair belongs. So we put 1, 2, and we say each of those dots represent electron. So which is methane. Methane we refer to as the natural gas. We are coming to find the Lorentz structure of. So now we realize that there is 1 carbon atom and 4 hydrogen atoms in each of these compounds. So now, what is the valence electron of carbon? We know that the valence electron of carbon is 4. So, and there are 1 carbon atom, we are saying 4 times 1, which will give us 4. And we look at the valence electron of hydrogen, which is 1. We are saying 1 times 4. 1 times 4 now, it will give all 4. So altogether we have about 8 electrons in this particular compound. So how do we draw the Lewis structure of methane? So we carbon have the ability to bond with 4 different atoms. So now first we put our carbon as a central electron because hydrogen can have a central electron. Say hydrogen can have a central electron with you. Since hydrogen cannot be central electron, we use carbon. So we said carbon had the ability to bond with 4 atoms. So we said single bond, and single bond. So we realize there are 4 single bonds, there are 4 bonds in there. So we represent each of the thing with hydrogen. Hydrogen, and hydrogen. And we said each of those bonds represent 2 electrons, and we have 8 valence electrons here. So let's count the number of electrons that we are there with. We get 2, 4, 6, 8.